Hello, I'm here to provide some comments on the results of exam one for you so that you have some idea of what to focus on as you study. I'm going to make some quick comments about each problem and I'll give further instructions on retesting later on through Canvas. We're going to first look at number one. Most people got the first four correct, but for the fifth one, people seem to mess up a lot in general. Uh, Rather than giving away answers for 1 through 5, I want to talk about what's going on in each of these four graphs, A, B, C, and D. And just, you can use that information to help you figure out what the answers should be for 1 through 5. So I would strongly encourage everyone to redo this problem once you hear out my descriptions of each of these graphs. All right, graph A. First thing I notice, I'm going to zoom in here. Graph A, what's going on with graph A? This little open dot here means that the function is not defined at x equals 1. Okay? The limit from the left and from the right is equal. Those two limits are equal, which means the limit exists, but there is no function value here. That's all I'll say about that one. Now, what about graph B? Graph B, what do we have going on? It's very similar to graph A. You have no point here. You have left and right limits equal to each other, which means the limit exists. But the function is defined at x equals 1. It's just that the function value is 1 instead of 2. Okay, so the difference between A and B is that in A, the function is not defined at x equals 1, but in B it is. It's just not equal to the limit. Now for C, what do we notice here? C has, there's an open dot here and a closed dot here. So the function is defined at 1. The function value goes with this closed dot. The left limit and the right limit appear to be different, which tells us that the limit doesn't exist. So I'll just say that much. You can figure out the rest when you look at 1 through 5 again. And finally, graph D, what do we have going on? There's no open dot here. There's no indication that the function is not defined here. It's just a cusp. So the function is defined at x equals 1. That's not an issue. The left limit and the right limit seem to be equal to each other, and the function is defined at that same point, and it looks to have the same value as the left and the right limit. So use that to draw the conclusion as to what you think is going on. I think some of you might have misread this graph. You might have thought because there's a corner here that the function is undefined here. It's not that the function is undefined. You might have been mixing it up with the derivative. The derivative does not exist at this point, but this question was just about limits and continuity. It wasn't asking anything about derivatives. All right, now about number 2. What comments do I have regarding number 2? Well, in number 2A, what a lot of people did was they separated it out as two limits, like this. You can only do this if you know that the two limits each individually exist. So that was not the approach that was desired for this problem. For part B, you have to think about what's happening in the numerator and what's happening in the denominator as b gets closer and closer to -7 from the right. Some of you did some graphs to help you with that, which is a good strategy. But I really want you to think again about what is this graph doing. You could try plugging in numbers that are really, really close to -7 from the right. So you're plugging in things like -6.99, -6.999, and you're gathering that as evidence to tell you what's going on. Even better would be if you could do a graph. So one thing you could do to remind yourself how to graph this is you could actually do the polynomial long division and then use that to determine what this function would look like if you graphed it, and let that help you decide what this limit should be. For part C, that one was a straight up multiply top and bottom by the conjugate of that numerator, and by algebra you'll be able to figure out that there actually is a limit. A lot of you said that there isn't a limit, so you should all definitely redo that problem and refresh your memory on that. Now for number 3, the major thing that I noticed is that people kind of ignored this instruction, the limit definition of the derivative, and then I even said either version of the definition is okay. So there were 2 definitions of the derivative that we learned about. One was the limit as x approaches, I'm going to use 2 since 2 is the number here. Limit as x approaches 2 of f of x minus f of 2 over x minus 2, which some of you used. That would be f prime of 2. Others of you used this definition, limit as h goes to 0 of f of 2 plus h. Remember, usually this 2 here is an a in general. Some of you kind of got confused about, do I put a, do I put 2? You weren't really sure what to do with the 2. So limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. And then some of you did f prime of x using this second version over here. So something like this, except you did x instead of 2, and then you later plugged in 2. So those are all three valid ways of doing this problem. Whoops. So definitely review how to do the definition of the derivative. When you get to Calc 2, you'll learn how to do derivatives with new functions. So you'll have to remember this definition. Okay. What about number 4? I did say repeatedly how important this idea of the equation of the tangent line is. So some of you didn't know that you needed to take the derivative. Some of you took the derivative using the definition, even though I said you didn't have to use the definition, and some of you were successful with that and it was fine. But one big issue I also noticed is that you didn't use your given numbers. We want the equation of the tangent line at a particular point, which means if you calculate the derivative, you need to plug in the given x value into that derivative to get the slope of the tangent line at that point. So definitely review this type of problem. It will come back. Number 5 was mostly pretty good. A couple of issues I saw is people used faulty exponent rules. So I saw more than one person use this faulty rule, t to the 1/2 times t squared. People were saying it was equal to t. That's just not true. What would it equal? What do you do with these exponents? When you're multiplying powers, you add the exponents. You don't multiply the exponents. So some of you messed up on that. You should definitely review your exponent rules to fix that. Another one I saw, t to the 1/2 times t was t to the 1/2. That's another example of just multiplying the exponents. So that's also not true. Another thing I saw was people were writing, this problem was defined in terms of t, and people were writing d dx. But you shouldn't do d dx of a problem where the function is defined in terms of t. You should actually be doing d dt. I didn't take points off of it for anything for that, but you really need to be careful and be aware of what you're taking the derivative with respect to. Finally, on this problem, one more thing. Some of you got a t to the 3/2 at one point, and then you wrote it as the cube root of t squared. It was more than one of you that did this. That's not true. T to the 3/2 means the square root of t to the 3rd power. So probably a good idea to review exponent rules, and then you'll do well on a problem like this. Number 6. A lot of you did a good job of remembering the derivatives of these two trig functions. So if you did that much, I probably gave you mastery for the problem. But even if you got mastery, meaning a 3 or higher on this problem, some of you forgot to use the product rule on this part of the problem. So you definitely should have used product rule there. For number 7, it was CD3, which means this problem I'm assessing you on the product rule, which means I expect you to use the product rule. So some of you didn't use the product rule here. Even if you distribute this sine x onto each of these terms, you're still going to end up having to do product rule at some point in this problem. So if you completely neglected to do the product rule, you definitely did not get mastery. One other quick comment, even though it's not related to the product rule, a lot of you took the derivative of pi to the 7th and you got 7 pi to the 6th power. But one thing you have to remember in calculus is if something's a constant, when you take the derivative of it, you always get 0. Pi here, I know it looks like it's a variable, but pi is a number. And it's being raised to the 7th power, so it's still just a number. Which means when you take the derivative of it with respect to x, you're going to get 0. This part here is just going to go away. So be careful about that kind of thing in the future. It probably didn't prevent you from getting mastery if you messed that up, but I wanted to be sure to tell everybody to watch out for that kind of thing. And then finally, number 8, people did pretty well. It was interesting that more people did well with the quotient rule than the product rule. So it looks like people studied the quotient rule much more than they did the product rule, or maybe were not able to identify that product rule was happening in other problems. So for part A, some of you actually figured out a way to do it without using the quotient rule. Some of you used the fact that it could be x squared over square root of x plus 1 over square root of x, and then rewrite things in terms of fractional exponents. That's totally fine. I strongly encourage doing things in an easier way if you can find an easier way to do something. For part B, though, you couldn't really get around you couldn't really avoid using the quotient rule. I think the major issue with a lot of people for this problem was you mixed up the two terms at the top of the quotient rule. So the shorthand for quotient rule would be f over g prime. It should be g f prime minus f g prime over g squared. Some of you mixed it up by reversing the two terms in the numerator. So that's something you should definitely review. And that's it. Those are my comments for exam 1. Again, I'll give you more instructions soon about how I will retest some of these. And again, we're not going to require mastery twice for every single standard because we just don't have the capacity for that this semester. So keep studying hard, and I wish you well on the next test.